Alright, so let's face the question that every probability class has to face. Students have taken some probability theory and they want to hit the casinos. Well, good, you want to hit the casino, so the probability that you're going to want is the chance that you make money. So we're going to figure out the chance that you come out ahead if you play roulette, and the bet that we're going to look at is the split. You've seen this before in an exercise. You are betting on one of two pockets. You have chance 2 in 38 of winning your bet. All of the 38 pockets are equally likely. And when I say pockets, I'm thinking of a roulette wheel. It is a wheel that has a spindle going to the center of it, and there's a ball in the wheel. When you spin the wheel, the ball ricochets around the edges and finally comes to rest in one of the pockets, and that pocket is the winner. So you've bet on two of them. In other words, you're saying, I'm betting that ball is going to land in one of those two pockets. So how does this work physically? Well, let's say you're a big spender and you are going to bet $1 on a split, right? So the first thing that happens before anybody touches the wheel is you've got to show your dollar and hand it over. So there's a person called a croupier, and this person takes your dollar. You say, I'm going to bet on this split, and they take your dollar. So nothing has happened yet, and already you're out of money. Then the wheel is spun. And this is the moment where there's some beautiful lady spinning the wheel and people are rubbing their lucky horseshoes and somebody's going, yeah, baby, go. And there's a massive fuss so as to distract attention from what fools these mortals be. And in the end, that ball comes to land in one of those 38 pockets. If it happens to land in one of your two pockets, then they give you your dollar back and now you are at zero, and they in addition give you $17. So they've handed you $18, but one of them was yours in the first place. So your net gain is 17. This first number in the payoff odds is your net gain on $1 bet. What if the ball lands in any of the other 36 pockets? Yep, bye-bye dollar. So you have lost that dollar, and this one with a minus sign is your net gain if you lose your bet. So you either say the payoff odds are 17-1, or you say the bet pays 17-1, various locutions like that. And I am going to pretend that you're going to bet $1 on a split on 200 different spins of the wheels. That means independent bets. And I'm going to look at the chance that you come out ahead. And really, I'm not thinking from your perspective. As we've said before, we're thinking from the perspective of 200 gamblers playing this game, and really the casino, needs to see how much money it's going to make off these people. So we now have a machine for answering such a question. The total amount of money you make is like the sum of 200 draws from a box that has 2 tickets marked $17 and 36 tickets marked minus $1. How much do we expect to make? What is our expected net gain? There's a machine for doing that. Figure out the average of the box. It's our famous number, minus 5 1/4 cents. This was the same box average when we were doing the bet on red. You've seen it, I think, also for a single number. And the expected value of your net gain is the number of draws, 200 times this box average, and that's minus $10.50. This is something that you've seen before. So there's that minus, which came from this minus. The minuses are unavoidable. They're right there. So why do people gamble? People gamble because this is an expected value and they know you're not likely to hit this exactly. You're going to be off by a certain amount. And how much are you going to be off by? Well, that's really up to Tyche, but do you have some sense of how much? Yep, it's the standard error. How do you find that? Well, you find the SD of the box, and this is a remarkable number. You have a list of 38 numbers, so it's an ordinary SD, the root mean square of deviations from the average. And if you work that thing out, you will get $4. And so what you're saying is per dollar bet, you expect to lose 5 cents, give or take $4. That's pretty large, and therefore your standard error on your net gain is root number of draws times the box SD, and that's almost $57, and that is why people gamble. Yes, you expect to lose $10. But if you're even one standard error over that, you're making money. Yes, if you're even one standard error below that, you're really, really losing money. But we are in denial about that side of the curve. We will look at this nice, rosy, positive side. And what is it that we're looking for? We're looking for the chance that you come out ahead. That means your net gain has to be greater than 0. So you've got a curve centered at minus 10.5, give or take 57, and you want the area to the right of 0. So rough and ready approximation is you convert 0 to standard units. So 0 minus the center divided by the spread, and that is 0.185 standard units. Look that up on your normal probability calculator in the online text, and you've got essentially 43% chance of coming out ahead. And that's a substantial chance. 43%? Lots of people would say, I'll bet. Sure, 43% chance of making money. And then I come along and I say, you think 43% is large? Well, then what do you make of 57%? Because that's the chance you're losing money. Yep, exactly. It's larger. You shouldn't play. Every year there are the annual meetings of professional statisticians in the United States. 5,000 statisticians descend on some unsuspecting city. And one year that city was Las Vegas. And the casinos had been saying for weeks, the statisticians are coming, these people really know how to play, come and watch, it's going to be fun, everybody come. And so the statistician did show up. En masse, they showed up, and also the other people to watch these experts play. And all the experts showed up around the casinos. The roulette tables and all of the statisticians teach introductory statistics, and all of them have this minus 5.25 cents deeply ingrained in their souls, and they all folded their hands and they did not play. And so this spooked everyone else, because everyone else thought, well, these guys know what they're doing. They're not playing. I'm not playing either. And so it was dead week in Las Vegas that week. Statisticians were not popular. If you are having a casino party, do not invite a statistician. We will be the ultimate party poopers. Okay, so moral of this story is don't do this. The mathematical issue, however, is to note that this problem involves only two kinds of numbers, wins and losses, and you are actually capable of computing the exact chance, not an approximation, by techniques you've had for some time. So let's actually see how to do that. What we're going to work with is the number of times that you win. So you're betting 200 times independently, and each time you have chance 2 in 38 of winning. So the number of times you win is, yes, binomial. Binomial with n equals 200 and p is 2 in 38. Now what you're trying to find out is the chance that you make money, so you have to look at your net gain, which I have put in red because that's the color you're going to be if you keep your books. What is the relation between your net gain and the number of times you win? Well, every time you win, you get a net gain of $17, and every time you lose, your net gain is minus $1. And so you've got a little equation. Your net gain is 17 times the number of wins plus minus 1 times the number of losses. And that's 18 times the number of wins minus 200, and those of you who are in Stat 2.1x will remember that you did exactly such a linear transformation before. It was, I believe, the number of questions somebody got right on a test and their score on the test. The scoring was, so many points for a right answer, so many points for every wrong answer. You did exactly such a transformation. If you know the number of wins, you can calculate the number, you can calculate your net gain, and the other way around. So what is it that you want the chance of? You want the chance of coming out ahead. In other words, you want the chance that your net gain is greater than 0, which means 18W minus 200 has to be greater than 0, which means W has to be greater than 200 divided by 18, which is just over 11. W has to be strictly greater than 11. The number of wins has to be 12 or more. So what is the chance that you come out ahead? It is exactly the chance that a binomial variable with n equals 200 and p equals 2 in 38 is 12 or more. Can you find that? Yes, you can find that. You've got a binomial probability calculator. You will go to that calculator and enter in your parameters. You've got n is 200, p is 2 in 38, or your decimal value of that, and you want greater than or equal to 12 successes. And what's the chance? The exact chance is 36.3%. That's the chance that you make money. So the chance that you lose money is actually 64%. It's your approximation was very rough and ready, and it's in the right ballpark, but you know what? It's really not that great. You can do the exact binomial calculation, so just do the binomial calculation. Don't do an approximation. And some of you will be wondering, well, you know, we could have done this back in section 2.2. So why did we wait this long to do this problem? Because this way of formulating the problem does not show you so clearly that minus sign that your loss. That minus 5 1/4 cents. This is rather technical, and in this you lose the fact that for every dollar you bet, you actually expect a net loss. And that is why I deliberately waited until now, so that I could first slap you in the face with that minus sign, and then look at the technicality of doing the calculation exactly. So when should you use this method? You should use this method anytime you have a situation where your single trial is a success or failure. Then you can convert all of those problems in exactly this way to a binomial problem and work out the exact chance, or do the normal approximation to the binomial. And that will be better than any other method that you can use.